in this paper, and the paper is treated by chemical reagent. We can keep the DNA or the RNA for a long time. So if in this way we can maybe flow up the virus circulation in the field. But this work was done elsewhere, but never done in Africa, where the weather and also the condition is different. For example, they were done in Australia and also in Italy. It worked very well. They let the trap during 28 days. So this year we trained to pilot this in Burkina Faso. So the main objective really is to pilot this surveillance using FTCAT. But for that, we need to have a good trap. We can collect mosquitoes before really we use. So we compare different traps, and after we identify the sensitivity of the FTCAT to collect mosquitoes in the field. As a design, we use BG, CDC, and human double net trap, and we compare them to see what kind of trap is really efficient to collect Aedes in our setting. We just modify a little bit of a BG trap by putting guinea pig and CO2. For guinea pig, we put guinea pig in a live guinea pig. It's a live guinea pig. And also to produce CO2, we use yeast. We put yeast here and sugar to do a fermentation. We collect CO2 here, and CO2 is rely in the trap. They can attract the mosquitoes. We use the Latin square design to compare the different traps. After the comparison, we have chosen the best trap, and we modify the trap to insert the FTCAT. This is, for example, the BG trap we found is really efficient to collect mosquitoes. We put a small device here, put sugar, is a sugar, glucose water, and we put also filter paper in the blue here. When the mosquitoes enter, they feed on the paper, filter paper, and expel virus. And 1 week after, we can collect only the filter paper to test if by PCR if the virus is present or where. We set up around 30 traps in 3 different areas around Ouagadougou. In terms of result, this is the result of different trap comparison. As you see, the HDN collect more mosquitoes and more diverse species comparing to CDC and BG trap. But if you see in the BG trap plus CO2, the BG trap plus guinea pig collect more mosquitoes comparing to the BG trap plus CO2. If this is the diversity of mosquitoes, if you take in terms of the number of mosquitoes collected, this is also the result showing that HDN is a human double net collect more, flowing by BG2 plus BG2 plus CO2. This is all mosquitoes collected. If we go to Aedes species, we found that there is no really significant difference between HDN and also between BG plus CO2 or BG plus guinea pig. So we choose to go through the experimentation with BG plus CO2. Thank you very much. Okay, so we set up a 30 trap using BG plus CO2 and FT card. Let's open. Okay. We success to collect around 100 Aegypti out of 11,000 mosquitoes collected. And we collected also 245 FT cards where we will identify virus. We did around 84 pool of Aedes mosquitoes, 10 per pool. And unfortunately, I have no data because of a sample still in identification at the laboratory. For other activities in the country, we in April, the Minister of Health informs that there is a case of Zika in the central part of Burkina Faso. We did some investigation, and when we got information about Zika, it's a patient of 6-year-old. The illness onset was October 2004. They collected sample and they sent it to the reference laboratory. But the identification was done in April, between October to April 2005. So it means that the information came very late. We did not get a chance really to make a good investigation. Anyway, we went to the place, tried to see if we can collect some mosquitoes around. But because it's the dry season, we did not success to call mosquitoes, but we found some breeding site we can be suitable for mosquitoes breeding site. Like jar, animal fruit, barrel are more abundant in the place. So we suppose that maybe during the rainy season, this is a breeding site which is helpful for Aedes breeding. The another activities in Burkina Faso is the launching of the kick-off meeting of dengue project. Dengue project led by Professor Atanas from the University of Ouagadougou. And the goal of this project is really to strengthen the arbovirus surveillance and control in Burkina through integrated community-based approach. This project was funded by National Institute of Health and Care Research from UK. And we work in collaboration with London School of Liverpool School of Tropical Medicine, IRSS, and the university. And you have a group of David Whitman and Badolo. They say that they are sorry they cannot come this year. Probably the next year we will come with some results of the project. The project have many activities we call work package. The first is really to identify arbovirus risk index, to develop new arbovirus risk index, and also to set up a digital mosquitoes surveillance, and also to perform some vector control intervention as a pilot based on community-based larval source management, and also to have a capacity building. If a project plan to train 7 PhD, has maybe in the site of WAASuN you have this call, I think that we call is ENDS. And also to see how community has engaged and involved in dengue control. Also, the other activities, Burkina Faso is trying also to see how we can introduce Wolbachia for dengue control. As you know, Wolbachia is is a bacteria we can use, for example, to control Aedes. And to do that, we start for risk assessment approach to see if when we will release, we will not get faced to a problem of releasing. So a risk assessment was done by expert consultation and also risk identification. We did also a community questionnaire to estimate probably the impact of the release of Wolbachia. The finding is that generally there is a low risk, low neglected risk for releasing the Wolbachia in Burkina Faso. But the social cultural acceptance is a problem because people rarely ask, very scared about releasing mosquitoes in the population. So it's still a big problem, and this is increased by the social media, because there is some, how you call in French, activists who can say that the mosquito will maybe increase the disease, or some mosquitoes can sterilize people. This is some kind of message they release through social media, so making a problem for releasing mosquitoes. So this is really, the social acceptance is really critical for that. So we need really to work on that before we release these Wolbachia mosquitoes. So another activities is the study of is the Aedes project from TOE. Is trying to study the ecology and behavior of insecticides resistance of Aedes aegypti. I think that I don't want to go through that because Friday he will also present the result of these activities. Okay, we have what's happened? Okay. The challenge is still the same until 3 years ago. We have the plan, the arbovirus plan, surveillance plan, but never implemented. Never. Every year we revise, or if 2 years we revise the plan, but no activities. We rely to different project results. So because they say that there is a lack of fund. So what we are thinking now is maybe if we can work with a malaria program, we have more resource, and we can maybe exploit this way to have a good surveillance system. This is really what I want to share with you from Burkina side. Thank you very much for your attention.
Thank you. The next presenter.
Yeah, okay, thank you so much, Burkina. The next presenter is the chair itself, is Benin. So, but we can take the question later. So you can come and sit down, and then at the end of the session, we do like the first time, and then all the presenters will come on stage, and then we ask questions. So write your question down for each of them. So we are going for Benin. No, clique sur les liens seulement. Eh non, fais la flèche. C'est la flèche. Benin.
Quand l'AS finit de faire un travail,
Clique Benin. Aha.
tu vois maintenant.
Okay, so 15 minutes for yourself.
Okay. I'm a president, I'm a boss. So okay. Good afternoon, ladies and gentlemen. It's always a great pleasure for me to see you, and this year see you once again, because all of you, you are still beautiful. Yes. I can see your smile. The title of my presentation is Genomic Surveillance of Dengue Virus in Benin. Last year, I present it on the mosquitoes. This year on the virus, that means from the blood, and then we can detect the virus. Because what you present, what you are saying this morning, you are saying that the mosquitoes is resistant. What is the final goal? If mosquitoes bite me, shall I say this mosquitoes is resistant to insecticide? Nobody will not listen to you in the hospital. What you want to listen is what? Do I have malaria? Do I have dengue? What I have. So if mosquitoes is resistant or not is not what is very important. Do I have dengue? This is what I will tell you. Okay? So please listen to this. WHO said that the global burden of dengue in 2024 highlights that mosquitoes-borne disease seem to be very important. With over 14.1 million cases they reported in the world, they realized that mosquitoes-borne disease is now regarded as the most important mosquitoes-borne disease in the world. Despite the lower cases of dengue reported in Africa, we are realizing that since the last decade, many outbreaks of dengue and many deaths were recorded in many countries, as you can see it here. That means that dengue seems to be very important and malaria is becoming down. We'll discuss. In Benin, epidemiologic data showed that before 2019, there was a lack of data on seroprevalence of dengue in Benin. However, from May to July 2019, the country has faced its first outbreak where we record 500 cases with 30 deaths. This is very bad and very sad. I lost one of my cousins inside. It was very bad. Sorry. Faced with the multiple annual outbreak, because from 2019, annually we have outbreak of dengue, and this disease is spreading in different districts, as you can see here, with many deaths. In front of this situation, we decided to investigate on the dengue infection and the different serotypes which can be responsible of the disease transmission. To attain this goal, ladies and gentlemen, we decided to collect 400 plasma from suspected patients who have clinical symptoms of dengue. These plasma were brought to the lab, and after reception, the blood were inactivated. Why do we inactivate the sample? Benin is very close to Nigeria, and yearly we have outbreak of Lassa fever. Lassa fever is close to Ebola. So if you don't pay more and more attention, you will contaminate yourself. So anytime you receive sample like that, you have to inactivate. So we inactivate the sample, and RNA was extracted from the inactivated sample by using Qiagen kit. The RNA was we amplified the RNA by using Altona Den kit 3.0. The positive samples from this amplification were used to detect the dengue. So the positive coming from the PCR and the CT value is equal to 28. We use them for the sequencing activities. What we are saying that is positive on PCR If you do the sequencing can show you that it is not totally positive. Therefore, the first thing you have to prepare your library. If someone is familiar with sequencing activity, they can understand what we are saying here. I don't want to go deeply in this activity. And after that, we use QB to quantify the DNA, and also the tape station in order to search the size of the amplicon. The results of our sequencing show that 4 samples were positive on dengue. As you can see here, D28, D40, D6, and D23. Now, we need to do the phylogenetic tree in order to know the source of our dengue, which is positive. My sample, which is positive on dengue, which serotype is it, and what is the origin? First of all, you have to take your sequence and you search it in Gizzard. Then you blast, you map alignment, you do the visualization, and finally you get your fig tree by using this software. Our results show that the sample named D6, the sequence is very close to those of Nigeria in 2021. People of Nigeria in 2021, they report that they have dengue serotype 1. Benin also in 2024, we had dengue, and this is very close to what people get it in Nigeria, but very different in what they got if you use this expression. This is why we have our own strain on dengue 1. When we continue, we realize that our sample D28 and D44 have the same claim as Burkina Faso in 2017. If people of Burkina Faso, Musa, if you remember, in 2017, you have outbreak of dengue fever, and what we had also is very close to what you had in Burkina Faso and close to what Maulud has in 2018. So it's the sequencing which can show you what you had and the origin. The challenge of our work, it was very complicated to get the ethical approval because nobody doesn't want to accept, give us the ethical approval. But finally, the Ministry of Health, they played the goal very well, and finally we get the ethical approval. Concerning the recommendation, genomic surveillance activities are very important to confirm all our PCR results. I suggest to WAASuN's scientific committee to promote these new tools. In fact, all mosquito you name Aedes need to be confirmed. Thanks very much, and I would like to express all my grateful to people of WAASuN who pay my ticket to be here, people of Bernard Notch Institute and the Institute of Virology of Charity who gave me the reagent, and Germany government who gave me the devices to do the sequencing easily in Benin. Thanks very much for your kind attention.
Thank you so much. I feel like asking you all my questions, but I keep them because I have plenty. So we move to the next country, Senegal.
Thank you very much, and thank you for this opportunity to present the Senegal update. To begin, just an overview of the arbovirus situation in Senegal in 2024. First of all, for dengue, we get many cases around the country, and you can see here. Oh, the pointer. The pointer. Okay. You can see here that we have so many cases in Louga, in the central part of Senegal, as well as in the western part. And for Zika, even if the number of cases is lower compared to dengue, we have some cases in the western part as for dengue. And for the two other viruses, yellow fever and chikungunya, we found that two cases, one in Podor in the northern part and one in the southern part in Velengara. And for chikungunya, all the cases was focused in the southern part near Kedougou and Tambacounda. And these data are from the Syndromic Sentinel Surveillance System network in Senegal, which is shared by Pasteur Institute and the Ministry of Health. In this situation, we have 5 main projects dedicated to monitoring and surveillance of Aedes vectors. One was funded by WHO TDR, one by CDC, one by Gates Foundation, NMRI, and WAASuN. And for this, we had 7 sites that was distributed around the country. And these sites are situated into the main domains, eco-climatic domains, one in the Sahelian area, Rosso, one in Anyam in the western part, 3 in the around the coast in Dakar, Mbour, and Louga, and 2 in the southern part in the country. And you can see here the number of neighborhoods who were surveyed, as well as the number of ovitraps that were set up in the different localities. And the methodology was quite classical, with the collection of eggs using different ovitraps, as well as collection of adult mosquitoes using double net traps, and aspiration inside houses and outdoor and indoor. But we also used BG sentinel traps. And in the lab, the samples was processed, egg was counting, hatching to get the adults and identify them. And we did also insecticide susceptibility test, as well as diagnostic to detect the virus by PCR, by ELISA, or by sequencing. In terms of results, the main results we obtained in Dakar showed that the densities of eggs, the mean densities of egg per ovitraps was very high during from August to October, which correspond to the rainy season. And we see that at the beginning of 2025, the number of eggs decreased. And the same pattern was observed when we look for Anyam in the eastern part. We see also that the number of eggs per ovitraps were higher during the rainy season, which is quite different from the result presented by Kofi in Togo this morning. And in the 4 sites that were investigated within the CDC project, we see that when we estimate the Breto container and house indexes, we see that during the rainy season, all these indexes was above the risk estimation threshold by the WHO, meaning that the risk of transmission is higher during the rainy season. And concerning the adult mosquitoes, when we collect the mosquito in Dakar, we found that around 40,000 mosquitoes collected in Dakar. We had 8 species with 4 genera, Aedes, Anopheles, Culex, Scinkifasciatus, Culex, and Marsonia. And we found that Culex scinkifasciatus was the most abundant species, and Aedes aegypti represented only 13 to 10% using the two collection method, aspiration and BG traps. And the same observation was made in Anyam, in the eastern part, where we found that about 20,000 adult mosquito was collected with 17 species and 4 genera. And as for Dakar, Culex fasciatus were also the most abundant species, and Aedes aegypti represented less than 70% of the collections. And when we see the other sites, we found that more mosquito was collected in these sites, and this is represented by 26 species, and Aedes aegypti here represented only 11%. That means that even in the sites which are rural, Aedes aegypti is less presented compared to Culex fasciatus, which is more abundant in urban sites. And when we look for biting, resting, and feeding behavior of the vectors, we found in Dakar that concerning the biting pattern, we found that many of the mosquitoes bite outdoors. And in terms of resting behavior, they rest indoor, meaning that the location of the biting is not the location of the resting of the mosquitoes. And when we see the feeding behavior, we found that the mosquito bite mainly human with anthropophilic rate around 90%. And when we see the 4 sites in the CDC project, we found that Aedes aegypti was collected or seeking mostly outdoor, like what we have seen in the last slide. And in December, we have found that the mosquito was collected mainly resting indoor, meaning that in this context, maybe using some control tools like IRS can be effective against Aedes aegypti. So in the first site, when we see the variation of the densities of the adults in the first site, we found that depending on the site, the method of using BG sentinel trap with CO2 is more effective than the aspiration. And it is quite different when we look the area of Rosso in the northern part of the country. And in this area, sometimes we have some cases of dengue. And for feeding behavior, the same pattern was observed with Aedes aegypti that bites mainly human population, what we have found also in the other localities, and which is quite different from the result we obtained in July 2024. And the same results were also observed in the CDC project, where we found here in green that the number of mosquitoes that bite human is higher when we compare it with other hosts that has been bitten by Aedes aegypti. We also did some insecticide susceptibility tests, mainly in the locality of Anyam in the northern parts. And we found that when we use the normal dose, you have here the normal dose of alpha-cypermethrin and the other insecticide, we found that all the population was resistant. And even when we use the intensity dose, where sometimes the doses are multiplied by 10, we also found that except for permethrin, all the population was resistant to this insecticide. And we have looked for some mutation, mainly this mutation, and we found that the frequencies of the mutation was very low. And sometimes when we compare the percentage or the frequencies of this mutation between alive and dead specimen, we found some differences. This means maybe there is another mechanism that is involved in the resistance observed for this population. And for viral detection in Anyam, in the northern part, no virus were detected, even if we have looked for dengue, chikungunya, Zika, and West Nile. But in the 4 sites in Kolda, Luga, and Rosso, we have found that in Mbour, there is no detection of virus. But in Kolda, we have these three serotypes was present, dengue 1, 2, and 3 in Kolda, in the southern part, 1 in Luga, in the central part, 2 in Rosso in the northern part. And in Dakar, we have found 15 positive pool, and the identification of the virus is ongoing. The last study was focused on the aerial sampling surveillance in Kédougou, and the aim of this study was to investigate the long-distance movement of vector and their associated pathogens. And the design was quite simple. This is in an area, an open space, with different features, with different criteria, at least 150 meters from large trees, and more than 5 kilometers from the nearest airport, and some other features, which means that the balloon that is used can be released in the altitude. And this is a balloon that is filled by non-flammable and toxic helium, and the sampling altitude was at 180, 160, and 13 meters. But also we conducted some ground level collection as control tools. And you can see here the different panels which were set up at the different distances and which can collect the mosquitoes that fly away. And this is just an example of the protocol we used to identify the different mosquitoes, but as well as identify the virus that can be transmitted by these mosquitoes. And in terms of results, we found that in the control altitude at 1 meter and 8 meters, very few mosquitoes was collected, and the highest number of the mosquitoes were collected at 18 meters, meaning that this is probably a passive circulation of the mosquito due to the altitudes. And when we look for the different species collected, we found that some species like Culex wati, which is sometimes collected in the area of Kédougou at very, very low abundances. And here we have found that this species was the most abundant species. And we have also collected some other species. And one new collection was Aedes albopictus, which is not reported in Senegal before this study. And we have collected 4 specimens of albopictus, which means that this species is expanding its geographic range. And you can see here the different countries and the year where the species were first reported. And as a conclusion, we need additional effort to investigate these species, mainly at the ground level, as we never collected these species, even if in all the surveillance activities, we never get these species. And when we look for the mean hike where the mosquitoes were collected, we see that except this species, Iranotenaeus abdominalis, all the species was collected above 8 meters, which means that this is probably because of passive mosquito migration by land. And for preliminary metagenomic results, we have found that we have 160 virus and phages that was isolated from this mosquito collected. And for viruses, there were many viruses collected, and all of these are of medical, veterinary, or biocontrol interest. And you can see here we have some bocavirus, some beta herpes virus, and some other viruses that was identified from these species. And as well as we get some phages, Escherichia phage MU and Shigella phage MU. So thank you for your attention. It was the result I wanted to share.
Thanks so much, Dr. Dia. It was really, really interesting, and then I'm sure you'll have a lot of questions when we merge Benin and Dakar and Senegal. We see there are a lot of questions coming, so get your book ready.
Thanks very much. The next speaker is coming from Gambia. Okay.
Hello, good afternoon. I stand on the existing protocols. My name is Samuel Gomez. I work for the National Malaria Control Program as the focal person for vector control. Today I present the country updates on our viral diseases. The presentation outline will be looking at the introduction and our viral diseases history in the Gambia. On activities conducted in 2024, the results, and also challenges and recommendations. Basically, the Gambia is a small country, but culturally rich nation. We are bordered with Senegal, and on the three sides, Senegal is bordering with the Gambia, except for its coastline along the Atlantic Ocean. It is obviously located in West Africa. We have an area of about 10,685 square miles. The stretch is about 330 to 360 kilometers inland, and then 30 to 40 kilometers wide on both sides. A population of about 2.8 million by the GBO census 2023. I know many of us will be saying it's a very small country, but then we are scorpions. The Gambia is the scorpions, and it is always said, a scorpion is small, but it can make a lion to dance. So we will make the whole room to dance this afternoon. Yellow fever, for the last yellow fever outbreak occurs in 1979 and 1978, 1979. But recently, epidemiological data indicates a resurgence of arboviral because it has been neglected, because the malaria control program is basically focusing on the Anopheles species. We have also West Nile virus. We had an outbreak in 2023. For Zika virus and dengue fever, we've not experienced any outbreak, but the country is still on watch mode on these two diseases. Lymphatic filariasis outbreak also occurred in the Gambia in 1950. In 2013, a transmission assessment survey shown that zero site-specific infection rate of lympharesis. As a result, the Gambia was classified as a non-required preventive chemotherapy for LF control in 2015. A study that was done in 2015. The country, yet still the country is on watch mode for any of this outbreak. In the Gambia, in 2023, we set up some sentinel sites for monitoring arboviral diseases in the country. A retroviral record review were conducted in 2024 in Central Region using the surveillance data from routine for monitoring. We have two sites that we have instituted. That is one in the far up country in the rural countries, that is in Central River, and then we have one in the cosmopolitan area, that is the western region, close to the capital. The syndromatic sentinel surveillance network also is in place in the country. Laboratory confirmation of viral cases from 2023 to 2024 by the National Health Laboratory Service, the Epidemiology and Disease Control, and the Pastoral Institution of Dakar. Experience such. Not only with arboviral disease, but even with malaria control indicators, it has also affected the acceptance. Trend in vaccine coverage and assessment, the Gambia's risk of focal transmission due to environment and epidemiological factors. The two sentinel sites that I talked about for arboviral surveillance in the country, we have one in Brikama and also one in Bansang General Hospital. Trained surveillance officers also are trained, and they are stationed in these facilities for any detection so that they can pick up the case very early. Any patient that reports to the health facility and meets the case definition of arboviral or respiratory, like samples are collected, ranging from blood, stool, respiration, with a simple collection method. The collected samples are transported through a sample collection network to the National Public Health Laboratory. These people also, now the National Public Health Laboratory Lab has also instituted this networking. They have recruited some men with motorbikes so that they will be collecting these samples from the peripheral facilities to the regional health district hospital, and then the vehicle will transport it to the National Public Health Laboratory. For the results, the source is from the routine surveillance base and then the Sentinel network base. In 2023-2024, we had 32 suspects from the routine surveillance database, and out of this, 3 were confirmed for yellow fever. In the Sentinel site network database, we have 194 suspected above-viral cases. Out of these 194, we have 4 cases that turned out to be positive. Challenges. The re-emerge of yellow fever and other above-viral, because malaria control funds we are having, they are only from Global Fund. They are only interested in the Anopheles mosquitoes and not in the above-viral mosquitoes. So most of these cases are emerging. Lack of capacity building at the vector control unit. The Ministry of Health, there is also a vector control unit at the Ministry of Health, but most of those people, the unit is dormant, so it needs to be reactivated. So and this can only be done when they are trained on above-viral disease surveillance. Lack of funds, that is to conduct Aedes surveillance. We are not into it much, but I think with collaboration, we can at least work on something that we can get a good surveillance system for the Aedes surveillance. Manage Aedes breeding sites also. Most of the breeding sites we go is to collect larvae for after the IRS, for the Anopheles mosquitoes. But I think it will also be interesting to also have some Aedes sites that are managed also in the country. Recommendation, we will also recommend to engage donors to put funds in Aedes, because all the funds that we have is not concentrating or funding Aedes surveillance. The urgent need to strengthen re-emergence of yellow fever and other above-viral diseases. We will also look for capacity building for vector control unit in terms of diagnostic, high vaccine coverage for mitigation. Engaging also decision makers like WHO, PMI now we have one, PAMCA, and even WAASuN also, if possible. The National Public Health Preparedness Intervention against above-viral disease also. Encourage cross-border cooperation. Our neighbors, Senegal, Nigeria, and maybe Cape Verde also. We're trying to have some collaboration with these countries on above-viral surveillance. For acknowledgement, we thank the Ministry of the Gambia for supporting Global Fund, National Public Health Lab, the Institution of Pasteur in Dakar, where most of our samples are sent for confirmation. So we say a big thank you for supporting the country. The epidemiology and disease control unit are also helping to collect these data also in Bansang Hospital and Brikama Health Center. On that note, I thank you so much for your attention, please.
Thank you. The last speaker from this session is coming from Côte d'Ivoire.
Thank you. Good afternoon, everyone. I see we have at the end of the day. I think you have the last presenter today. So I saw some people sleeping. So I want you to stand up to be present with me. So how we do in Côte d'Ivoire? So you have to clap. Will you help me? Okay, thank you. So we do like me. can sit. It's okay. You want to take again? Coming from Senegal? Okay. You start again. Please. Clap two. Clap two. Three, play. Okay, I feel okay. We'll stop like this. Thank you for you to welcome with me in the room.
Okay, you were having the authority, but we have authority within us again, so more than you. So let's welcome Prof. Boachi, just I think from the airport straight to here.
I'll join you tomorrow.
Okay. Thank you, Prof.
Okay, thank you. Okay, for Côte d'Ivoire presentation, we have to. Can I go? Okay. To present you with stringing entomological surveillance of Aedes mosquito for the prevention of arboviruses in Abidjan, Côte d'Ivoire. In my presentation, I will be focused on what happened in Côte d'Ivoire. The presentation gave all the information about dengue viruses. In Côte d'Ivoire, what we know in the 2 decades, we have many resurgence of yellow fever and dengue fever in Côte d'Ivoire. And what we observe is that between 2008 and 2019, every 2 or 5 years, we have a dengue or yellow fever outbreak. But since 2019, every year, we have an outbreak of dengue or yellow fevers. Thanks to this situation, we can think that we have a rapid urbanization, population movement, with a impact of environmental and climate change can increase this situation. To mitigate the impact of the arbovirus disease on public health, we carry out an entomological surveillance how to expand with our strategy on strategy site in the city of Abidjan to identify the map the primary vector species and access their role in the transmission. In addition, we have a benefits of malaria consortium support to access the epidemic response capacity. We have to work on the strategy a national plan helping by malaria consortium and our professor. Okay, so what method we use? We have many sites. Sorry. Okay. In the site, we work in Abidjan, in the seaport, in Vorboué, in the empty container park, in the train station, in the abattoir, in the University Félix Houphouët-Boigny domain, and living area in our country, in Cocody, Trècheville, Abobo. So how we collect mosquito? We use the same method for the hovers, using OV trap, lava survey, BG sentinel trap, and aspirator with Propobac. What analysis we do is the arbovirus research, dengue, Zika, and yellow fever by RT-PCR. So what results we get? In the seaport, we collect more than 4,000 specimens of mosquito 3 genera we compose and 4 species. The most important mosquito, Aedes mosquito we collect is Aedes aegypti. And the second is Aedes vitatus. The main larva breeding site is Eustire and the hole in the bitumen. When we see on every month, the monthly collect, we see we collect aegypti all the month in the peak in June. And the same June, we have a peak of vitatus. In the empty container pack, more than 6,000 specimens were collected, 3 genera and 5 species. We have again, aegypti is the more species collected, and Aedes vitatus. The main breeding site in this place we collect is Eustire. And we have a pool of mosquito we do, but we don't get a positive to all the arbovirus we need to detect. When we see in the monthly collect, we have every month we collect aegypti, and we have a peak when the rain begin, and we have the same peak for Aedes vitatus at the month of June. When we see in the train station, more than 9,000 specimens of mosquito has been collected, 3 genera with 8 species. The most important mosquito vectors we collect is Aedes aegypti again, Aedes albopictus the second, and Aedes vitatus. The main breeding site is still the Eustires. We pull 15-2 pull, sampling using PCR detection, no positive. When you observe the distribution in the monthly collected, you see again we collect aegypti all the month with some peak with the raining season. In June, we have more raining season, but the peak decrease. We have a peak of vitatus in the same month for all we present. In June, we are all the time vitatus. And this collect is very important in December to go to November to go to December with Aedes albopictus. The main larva breeding site we collect here is still Eustires. Thank you. And when you observe to the abattoir, we more than 7,000 specimens I collect, 3 genera, 5 species. Again, Aedes aegypti is the more vectors we collect, and the second is Aedes vitatus again. The main breeding site, Eustire, and abandoned container in this place. 11 a pool of some mosquito has done. The result analysis is still ongoing. When we observe on the monthly collect, we have aegypti was collected all the month. The peak of Aedes vitatus is still in June, where we also observe. Now we work in the domain of the university. Last year, we have worked on this place, which says the natural forestic area in the university. We show you last year in Dakar, we have collected the second time Aedes albopictus in this area. So we want to see in the domain of the university how it spray, Aedes albopictus spray. So in this area, in the few months collect, we collect more than 1,000 specimens, 3 genera and 3 species for mosquito. In the place, we have aegypti, with more species collect. We have albopictus, the second, and Aedes vitatus, the third. The main container in the place as abandoned container in the domain of the university, and we use tire. When you observe, we collect every 20 meters to go far from the center, the natural forestic, and we collect Albopictus in everywhere when we go far from the center, the natural center, forestic center. So we think it's going spraying to be all the place in the domain of university. You see, for in the over place, we collect in with train station. So I bought Albopictus as going to take place in all Abidjan. So for the next, for OAS project, so we work in 4 health districts in Abidjan: Abobo, Cocody Bergerville, Port-Boué, Vridi, and Yopougon West. The most important mosquito we collect is Egypti for all the sites. And in Cocody, we observe again Aedes vittatus in Vridi, and Aedes africanus in Yopougon East. When you observe, with more breeding sites we collect here is not right, is for the the container, abandoned container is the most, and after we use tire. So we pull 3 mosquito, 175, and we have 9 positive of dengue virus, 2 in Yopougon, 2 in Port-Boué, 2 in Abobo, and 3 in Yopougon. The most virus disease dengue 1 and dengue 2. So when you observe a distribution between monthly collectively since December 23, we have AGC will collect all the month, and we have a peak at the when the rain starts all the time, year. For peak of raining, the peak of raining is some raining in January, a peak raining year. A peak raining year, we have more collector for Aedes aegypti. Here we have more collector Aedes in Port-Boué and Abobo. This place is still rain, even if it's not enough, it's still rain at all the time. Okay. What's our challenge or recommendation? We still want to enhance our entomological surveillance and virological in the municipality. We want to access a very geographical expand of Aedes albopictus in all Abidjan and over city of the country. We want to continue work on Aedes aegypti to make a genetic variability on what is the challenge we want to do between the municipality in order to explain the recurrence of dengue cases. We want to again to analyze human-induced factors that contributes to the emergence of Aedes, the dengue case in Abidjan. We don't finish without thank Institut Pasteur, Public Hygiene, the University Domain for WAASuN for inviting here, negotiate our guests, women who help up to fund, who finance our work, CDC and ECOWAS. We don't want to finish without thanks the population of a study area on the 8th district. Thank you for your attention.
Thank you. Now it's time for question. All the 5 presenters, please kindly come here. Burkina Faso, Benin, Senegal, Côte d'Ivoire, Gambie, and Benin.
Super. So, as the chair, I've moved to the other stage. Oh, do you want a keynote speaker for yourself again? Because we have one for the first session, like, so, okay. Where's the second mic? Who is holding the mic?
The mic?
Yeah. Yeah, so, Who is it? No, 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 no. You have one. Okay. So after you back, and there you go. Good. So we'll be taking a few questions. I think Dr. Malu has a mic, so you can direct your question to the candidates. Okay.
Okay, I have a question to Ange. Ange first. Ange, you was talking about inactivation of your sample. Yes. And your explanation is, I am not convinced about your explanation. Okay. Because usually we do it, when you talk about Lassa for sure it is a biosafety level 3. That's why we inactivate. Yeah. But for dengue, it's not really necessary. Okay. And I think you're going to lose a sample for additional work you can do for anything. The second question is about, the difference between positive PCR and negative sequencing. Did you check your CT level? Because for me, it's just the quantity of RNA or DNA, but it don't make sense. And the other things is, I don't think that sequencing is more sensitive than PCR. This is a mistake that everyone is doing. For Gambia, just one thing, you talk about Gambia in which mode? While I know that the 4S surveillance system was implemented recently, and you detected dengue. Are you aware about that, and what did you do concerning the entomological aspect?
Okay. Thanks very much. Are you listening to me? Yeah. Thanks very much, Malud, for your question. Concerning the inactivation, this is a rule for WHO. Anywhere you had in the past positive sample of Lassa or Ebola, from this day, any sample you want to test, you have to inactivate. Like, I suppose the moment that my colleague, he's not positive, but he has a symptom, he has fever, everything. Someone who has Lassa fever has fever, and the symptom is very close to malaria, is very close to dengue. Then the technician will collect the blood and bring it to the lab. How am I going to know that it is not Lassa? How am I going to know that it is not Ebola? Imagine that I'm searching dengue and I do not inactivate the sample and I start working directly on it. Dengue will be maybe negative, but after I will do multiplex PCR and I realize that it's positive on Lassa or Ebola. This is very dangerous for myself. Reason why WHO recommend that if you have recorded in your country a positive sample on Lassa or Ebola or Congo Crimea, from today you must inactivate your sample before continue the different analysis you want to do. This is how they told us, and this is how I learned it from Nigeria, because they are working on Lassa fever before us, and this is how we are working together. Let me come into the last question. Sequencing and PCR. Between the two, which is more sensitive? Malud, I want to, if it is possible, to show you one of your slides that you go first with by searching one virus, but finally you got 160 virus. What does it mean? PCR will just show me one virus, but the sequencing, because it's more sensitive, it will show me more viruses.
No, here we are talking about diversity.
This is a diversity, and because it's first is diversity and more sensitive. Okay, well, I think during the coffee break, we discussed seriously, and I will show you that sequencing is more sensitive because how do we do the sequencing? We just use the amplicon of the PCR. So it's the same. Sequences is up to PCR. How do you do the sequencing? It's a positive sample, and the CT value is under maybe 28. And then you use it to do your sequencing. That means that it's sensitive. Yes. Because the debate will be very long.
This discussion will go further. Yeah. But I think it depends on what we are looking for. Okay, it depends on what we are looking for. So,
you use a technique depending on the OGP you want to.
Why do you use a qubit? We use qubit in order to quantify. And this, if the quantity is okay, then you can go further for your sequencing.
With RT-PCR, quantity cannot be okay, but you got something with RT-PCR.
Yes, but for sequencing, it depends on the city. Yes, it's because the quantity is not good.
Okay, that's what I'm saying. It depends on how we define what. So let's. Okay, so because I know when researchers are gathered somewhere, we start by one, we ended up not agreeing on everything, but we can cut it off. Tomorrow, I bring the same question. Go and read about it tomorrow morning. That is a take home for tomorrow morning to come for exercise this night. Tomorrow morning, we get the answer.
The last
we can
question.
See how many less sensitive or more sensitive. Okay.
The last question. No, yeah, yes.
Okay.
Positive, negative, positive on PCR and no, negative on PCR and positive for sequencing.
The opposite side.
Okay, so
side.
both. Okay, this is the exact answer. Okay.
He has to answer.
All right, thank you very much. Thank you very much, Prof. That's a good question that you have raised. Because if you look at the history of viral diseases in the Gambia, we said we have not been seeing them for almost 75 years now. But then what we are doing as a country, we are doing integrated surveillance, malaria control with epidemiology and disease control unit. It also copying the health promotion unit for community engagement and risk assessment, so that we can get these sentinel sites. So we decided to start with 2 sites for the viral disease data reviewing. So any person who reports at the facility, we take note, and then the sample is collected. The National Laboratory Lab also is part of this integrated within the national system of Ministry of Health, so that some other people, some volunteers are trained on motorbike and given motorbike, so that any suspected patient or person that meets the case definition for any of this viral disease, the sample is collected and transported to the regional district hospital, where there is a vehicle that transports these samples to the National Public Health Lab. And when the lab is, the diagnosis, the tests are done, they further send the sample to Senegal for confirmation. So these are the review that we are doing. And then at the last part of my presentation, I said we are also looking for more collaboration, because nowadays, mosquito does not have any ID card. So if we are bordering with Senegal, and Senegal is also seeing most of this viral disease, especially around Vélingara, as the presentation have shown, you will see that we have more malaria-borne cases around Vélingara and Basse, Vélingara and Bansang CRR that I have presented. So we have almost similar climate change, change of temperature, and then the global movement of people also. So people move from Senegal to Gambia, from Gambia to Senegal. So the mosquito can bite them, they come to Gambia and spend the night there, and they can transmit the the disease, the overall disease. So we'll be working in hand, and then we will try to work that out. I think this is why we pick up those few cases. But then with dengue fever, you will not call them few. We're trying to work out to see how best we can have a very robust system in place. Thank you.
Okay, so thank you so much for all the presentation. I have two questions. One for Musa and the other is from Côte d'Ivoire, from Sana. So I'm really interested in the methodology you explained, because I think it's clever. No, you are like doing the monitorization of the vector and the virus at the same time, but I'm not understanding really so good. How was the use of the FT card? So are you putting the FT card in the same places where you are doing the entomological monitorization? So where you put the trap, you put the card? Or you do this after when you take... sorry. Okay. Yeah, my English is not so good, sorry. I try to, I'm interested in the methodology you explain with the FT card, and at the same time capture the mosquito with trap, because you are doing the both thing, no? Try to monitorize the virus and the vector, no? But I'm not understand in totality your explanation. So you do this in parallel, so you put the FT card in the same places where you are putting the trap, or you do after when you collect the mosquito and do at the lab? And in the same idea is how many days you have to put the mosquito with the FT card? How many days to obtain? There is some pattern with this. The other for Côte d'Ivoire is really, I think you really detected where is the enter of albopictus, no? That is in the university, like you are explaining. So in this case, are you doing some special intervention to avoid spread in the city? Because in these cases now you can control, I think, or try to control before spreading all Abidjan city. Thank you.
Okay. Thank you very much, Lara, for your question. For the design, we first set up a Latin square design by rotating trap. So we all trap move to all places we identify. So to avoid any bias of we did it Latin square. We did it twice to increase the number of collection. So for how many days we actually 1 week, we set up 1 week and we move it to each. No, for this is for the FT cat, we put many trap, 30 trap around three places, different zone, and we let them run 1 week before we remove the FT cards. And we collect also the alive surviving mosquitoes inside. We put the mosquitoes in arena litter, and also the FT card we need just to dry and put them in -4 before we send them to the lab for RT-PCR.
So in parallel, so we do both.
Yeah, we will do both.
Okay, thank you, Professor Lara, for your question. And the question is, what I want to understand well is the intervention against the spray of albopictus in the domain of university. Okay. The first time when we saw this mosquito in the National Forensic Area, we have an intervention doing by National Institute Public Hygiene for another group. We have to spray to eliminate this mosquito. But this is new studies. We have to see after the natural forestic area. Even if we want to know if Aedes-Borne leave this place and go in Vietnam, that's the result we get. Well, now we have to return the information. We have a National Public Hygiene representative here. I think if he helps, if he can complete my answer. But now we can do a new work. We have to send the result first, and we have a decision for what we should do for the treatment of this area.
Okay, thank you. Thank you for all the presenters. Maybe I will have 3 questions. The first to the first to Musa, yes. No, I'm very happy to see that you start collection also using guinea pig as attractor. Guinea pig. Yes, you tested BG trap with guinea pig and with CO2. You found that there is no difference between BG traps with guinea pig and BG trap with CO2. But at the end, you decide to use BG trap with CO2. Why you prefer CO2? Is it easy to have CO2 than guinea pig? I'm still thinking. Now the next question is to Dr. Jia. I found also, I see in your presentation that you collect 3 samples of Aedes albopictus in high latitude. This suggests that this mosquito is passing through Senegal, and you catch them during the transition. or this species is really present in Senegal. Now the last question to Susanna. Yeah, I saw in your presentation that the Aedes-Borne in Côte d'Ivoire, in many areas in Abidjan, is just localized around the university. You collect around the seaport. You didn't find any specimen of Aedes-Borne, isn't it?
We collect it in the train station again. Train station.
Okay.
A part of the university, we collect them in the train station.
Okay.
As another people say that we collect in another area, but when we work with 4 districts, health districts in Abidjan, we don't collect Aedes-Borne. But in the domain of the university and the train station in Plateau, we collect Plateau and Treichville. We collect it.
In Treichville also.
Yes, in the train station.
Good.
Do you know Côte d'Ivoire better than the Ivorians? Okay.
Okay.
We
What?
I don't have. Do you have a?
No. She has a question for you.
Oh, for me. Okay.
No, we already answered his question. Okay.
Oh.
No, you asked me why I use a guinea pig. No, I don't use. I didn't use a guinea pig, and it's easy to use CO2 because guinea pig you have to feed to maintain them in the lab, and also managing animals is not easy. The right of
Animal rights.
yeah, we have animal right also. You need veterinary to follow up this guinea pig. Because if you want to publish, you need to see that you follow all steps. So it's better, easier. And also transporting guinea pig is not easy. And also in terms of ethical, so that if the population in the human houses settlement, if you put guinea pigs, some people are allergic, how you call it, allergy to that, so it's very really difficult. For CO2, it's easy to produce.
Okay, sure. For Albopictus, it is the first time this species is observed in Senegal. And right now, even if we have some sentinel site collection around Dakar, we never found it. Just some, or maybe from Mali, because it is described in Mali.
Okay, great. The last one from. Okay. The last, not the least. Okay.
Okay, thank you. I have two questions, one from Musa and the other one to Angie's.
I like
to Angie's. From Musa, in your presentation, I heard about the low community acceptance with regard to the release of the mosquitoes. So I would like to know what are the measures in place to ensure that the community accept the intervention while it's ready to be deployed in the community. And for Angie's, you mentioned that it was so difficult for you to get ethical approval, and we all know that the scientific work, the scientific and ethical integrity is part of the science. So could you maybe share what were the ethical concerns which lead you to the delaying or challenged you to get the ethical approval? Because this is very important, and if you could share, it will also be applicable to other countries represented here. Thank you.
Okay, thank you, Basiliana, for the question. Sure, the problem of the community is very, very important because maybe, as you know, we have a project we call Target Malaria. It is a genetic modified mosquitoes. We probably want to release in 5 common year. So the problem means that we were faced with this problem, mosquitoes releasing, because many people are scared about genetic modified mosquitoes. At the same thinking and same feeling, people say that Wolbachia probably is also the genetic modified organism. So we want to release in the field. So people are scared about that. But what we did is we set up a group we call a community engagement group. We discuss with people at the different step, at the different level, even in the village, just to inform them and also to give them the right information. In some village, we train people to recognize mosquitoes, to recognize the biology of a mosquito. If you go to the village, you take some people on there, they can say you the different stage of mosquitoes development. They know how mosquitoes develop, the behavior of mosquitoes. And at this way, we can maybe involve them in the decision. We work on them. If they are aware what we are doing, they will accept easily. And we want also to go step by step. We don't want to release everywhere. We will choose one village where they are more aware and where we are more involved, and we will release and take, for example, this will be, for example, a pilot and gain many results, many experience before we move to all the country. This is now what we are trying to do.
Thank you. Concerning the ethical approval, most of the time the duration to get the ethical, it's 6 months. and you have to pay 1,000 euro. So I paid 1,000 euro, and after 6 months, they returned the document to me that I should get Nagoya permits. So Nagoya permit, you have to pay 500 euro to add to what you pay to the ethical approval. So finally, it took 9 months before getting this foolish document. And my project is for 12 months. Wow. So I was obliged to talk to some people, members of this committee, that if I don't start the work, I will lose the money. So I start the work, and I was totally at the end before the paper came out. So I'm sorry to say something like that. Yeah. So 1,000 for the ethical, 500 for Nagoya, and when they return the document for you and you have to insert something, you must pay again 300. So totally 1,800.
Thank you.
Yes. Yeah, don't. Yes, please.
Said the last, not the least.
Yeah, this is the least question. So before you clap, wait for the list. Thank you very much for all the presentation. Incidentally, the question is for the two gentlemen that just spoke again. Please, Musa, in your presentation, you talked about, did you say HDN? HDN. Yeah, please.
Human double net.
Oh, okay, human double net technique. All right, I just wanted to be sure of that.
Okay.
Yeah, thank you, you're fine. And yeah, so, no, it's Ange. Are you running away?
No. We are sharing borders.
All right, no, I'm particularly concerned about this technique and the idea that you are pushing for the scientific committee to look into it. In my head, I'm thinking about the costs. I'm also thinking about the sophistication. So I'm thinking, how do you think we can push forward with that as something we want to adopt in the sub-region that you want the scientific committee to look at? Thank you.
If I understand very well, it's about the sequencing. Okay. Since COVID started, IPD Senegal trained many people like me to know some things about how to sequence samples. I had also the opportunity to come to Ghana and Gucci to be trained. Just to say that WHO and WAASuN, they have found to support. So currently, WHO and WAASuN, they are giving us some reagents to do to sequence our own samples. So some lab which doesn't have this capacity now, we can receive sample from you, from other people, and do the sequencing for you. So we can create a network and then work together in close collaboration with IPD and Ghana, because the two labs are the hub for WHO on sequencing. So I will be very happy to receive sample from you and do it. And most of the time, I share my results to people of IPD and Ghana, and we discuss about the bioinformatic analysis, and it's okay. Thank you.
Thank you. Do you have one? Question for yourself or for him? Question for Ange. No, I don't understand. Question for him? You have a question for Okay, I'm giving you 30 seconds. So 1 minute. Okay, you do your question to Ange first.
Thank you for when Ange talk about inactivation sample, I want to well understand what he mean by inactivate a sample. Is it possible to do a PCR without inactivate the sample?
Thank you.
The homework you are bringing again.
Inactivation sample is the first process in our lab in Benin and Nigeria, because yearly we had outbreak of Lassa fever. So any suspected samples which arrive in our lab, we consider the sample like Lassa or Ebola. We cannot manipulate the sample if we don't inactivate. So even if you have malaria and you don't bring the sample to malaria lab and you bring it to my lab, VHF lab, the first thing is to inactivate. Inactivate the sample is like when the blood is in ADT tube, you cannot touch it. You will be contaminated. Then we use the kits. And this kit, there are some solutions. And first of all, you add AVL, and after AVL, you add alcohol. And from this, at the end, you can manipulate the sample like water.
You kill everything that you...
The conclusion, you kill everything, and it is simple. But even you kill it, the virus still inside, but cannot contaminate you. The RNA, sorry. The RNA or DNA, sorry. Okay? Yes. Like mpox, we receive sample for monkeypox now. We have to inactivate again.
Now,
okay, cool, thank you.
Come to here now.
Okay, during your presentation, you mentioned that you found Albopictus in university area, is it? If in other area like Cocody, I don't know where again, Trashville, you didn't find any trace of Albopictus. So my question is, do you maybe what kind of explanation, maybe because there is a forest in the university area, you found Albopictus, or what kind of explanation can you maybe use to explain? Because in other region, I have seen also when you have forex, you can find it. In Burkina Faso, you look for this Albopictus. Even we found some over in Ghana. We never seen a trace of Albopictus.
Okay, thank you, Helder, for this question. I think we can have many idea for the introduction of Albopictus in Cote d'Ivoire. We saw the first time in the seaport in 2009. After that, we did not see Albopictus. Even with Basil have a project, they come in Cote d'Ivoire, we work in many places, we don't see Albopictus. 13 years after, we have some mosquito bite in the National Center in Inter University. We asked Professor Kona and Professor Gindo to do a job here to well understand why mosquito change their behavior. So when we investigate in this place, we collect Aedes albopictus. So a few years ago, we think about the work, the renovation we have in the university. The people who renovate this university come from Asia. They come with a container, they come with a trick, with all the things they need. That's what we are thinking about. But after that, we collect again in the train station in Trashville and in Plateau. So three are going to Burkina. So be careful. Thank you.
Don't move. Yeah, thanks so much. I think they deserve a big applause because other side of the river. So, why? Be there. Are you tired? Okay. I don't know how we arranged the country list, and they were all in the same pool of countries. I wonder, but next year I think of it. Anyway. Okay, thanks so much, guys. No more questions. But as I said, we are assignments. So there are some of the things that we would like to have deep understanding. Google is there. Seniors are around. Tomorrow we can continue some of the discussion that actually is a little bit confusing all of us. Sensitive, not sensitive, or PCR, not PCR. But one thing I would like to add is, Prof is not around, just step out, is about the training that Angie was talking about. I think Udoka tried to bring that a little bit in the corner, but it's something that as WAASuN, we may be thinking of. I think Angie and I was discussing here. So how to go with new tools if we want to move forward. And people need to be trained on those things. So how do we do about it? So I think we put that as, some of the note that the team need to look at it. Though we know the funding is becoming a little bit, but at least let's have it in our notebook and see who is available. Angie was saying that WHO, OIS, anyway, Paloma is here. She will carry some of the WHO and take it, and then we see what's happened. So we sit at room and, hand to say help us, because we need to do good, and we need, let's say, training and all those things that can support whatever we are. So thanks so much, guys. You are free. Okay, normally that's the end of the day, but I have allez, merci à vous. Some housekeeping. Where is my food? No, your chair is finished. Some housekeeping. I said it before lunch that we'll be going out for, I said dancing, so not by force you have to dance, but I'll go and see people dancing. For now, we have only 9 people on the list. If you want to go, I beg, we are going at 7, it's 5. So make sure you have your name on the list, because we'll be asking for the bus according to the number of people. If we have only 10 people, I have a car. Angie has a car, and whoever has a car, so we can just use that. But if you are plenty, we need to cater for another bus. So make sure before you step out, you say, yes, I'm going, or no, I'm not going, and we know how many people, so that we can be ready to see how to go. We all meet, those who want to go, we meet in front of where we took the picture this morning. We meet there, 7, and we go, okay? We know that tomorrow we have work. We are not going to delay. Normally we have 5 days when we do the meeting like that. Now we are having 3 days. So we pass some of the thing, and we cannot spread some time, but we feel like Senegal was high. We wanted to go close to Senegal, and everything was cut, but we tried to do good to make people feel also that they were in Ghana, they saw something before going back. That's why we are trying to organize these petty things for you, so that you won't feel lonely, like, oh, I went to Ghana, I was just at the hotel, and I came back. It doesn't look like, you came to Ghana. So that's why we are trying to arrange those things that people can at least, enjoy a bit before leaving. The second announcement that I have, the country focal person and the trainees see Eugenia before leaving. So I think she has a pen or pencil for you guys. So make sure you pass by Eugenia's table. Trainees first, or no, country focal person and trainees. So see Eugenia before leaving. Sorry, it's not money, I said pen. So that's the thing. Tomorrow we are starting, what's the time? At 9, eh? Okay. At 9, so registration will start at 8:30. So at 9, and you have the program. So the country that's, Eugenia, do you have all the country presentations? Which one do you miss? You have all. We have all. Daniel, where is she? anyway, so we checked it out. But I think all the country presentations are already been sent to Virginia. If not, kindly send your presentation for the pool of tomorrow, the country remaining. As I said, the meeting is online, so we have people for hybrids. Some are following us also from distance. So tomorrow we see if the people that cannot join us in person also will be presenting online. So thanks so much. Remove all your coat, take your T-shirt, and we go for Afrikiko. Thank you and enjoy the evening. See you tomorrow.